Hello, Mr. Wilford here. I just want to take some time and go through some of the material that you're going to be looking at here in the first week. Um, what I'm going to do actually is just go through and talk about each of the sections that we're going to be looking at here. And in this course, with the first week, we're going to be starting with Chapter 10, Section 1. And we're actually going to do 3 sections. And this is kind of an interesting chapter here. It has to do with conic sections, and there are all sorts of different types of conic sections that we're going to look at. So we'll get into that here in just a second. Um, I also want to just explain that as you go through the week, there will be a few different assignments. There's a discussion assignment, there are book assignments, and there are online assignments. So you want to make sure that you do all of those. Typically each week then, at the end of the week, there will be a quiz or a test depending upon where we're at in the chapter. Also, take a look around. Occasionally there will be different special assignments that you'll run across. You want to make sure that you look at those and do those as well. If you have any questions with those as they go through, please let me know. Also, if you don't know this already, there are some great links as you look through your online textbook. There are lesson tutorial videos. These are great examples. They're little video examples that you can use from your online textbook. And then for each section there is an interactive practice quiz. So make sure that you take a look at that as well. Those are for each section. They kind of test your knowledge as you go through each section. So I would recommend looking at those as well. And you can do those as many times as you'd like. They're very good. Okay. What I want to do then is just take some time and go through the first 3 sections here briefly, and just talk a little bit about what we're going to see this week. And in Chapter 10, the first section is all about the introduction to conic sections. There are 4 basic conic sections that we're going to be looking at, and some of these you know a little bit about already, hopefully. And we're going to talk about them more algebraically than geometry as we go through. Also, a good graphing calculator is helpful. Online tools like a graphing calculator online, or things that you can find, also will help you with some of these and visualize them. Okay, but I'll kind of talk about them real briefly, and then if you have further questions, please do let me know. Okay, in section 1 then, the conic sections are a circle, an ellipse, a parabola, and a hyperbola, and they're all formed by taking cones actually and putting them end to end, and then slicing a plane one way or another through the cones, and then you will get these conic sections that we talk about. Now, in the first section here, basically we're wanting to look at some equations and identify which of those conic sections we're looking at. So this is where a graphing calculator again comes in quite handy. In the first example, what they're showing us is they're giving us an equation, and what we want to be able to do is use a graphing calculator to sketch the graph of this and figure out what conic section this is. Now with a graphing calculator, typically most of them you have to be able to solve for y in order to plug them in. And so the first step here is solving for y, and notice that y is squared, so when you take the square root to both sides, you end up with a positive and negative side. You actually have to plug in both of those into your graphing calculator, the positive side and the negative side, and then what you end up with is this circle. If you're trying to find the intercepts, that just means where does the graph cross the x and y axis, and you can just read from your graph here where that happens. Going on to the next page here. In the next example, same thing is happening. You can see that we're solving for y, and we have a positive and negative. Now you have to be careful how you plug these in to your graphing calculator. It can be a little bit tricky. Make sure you use some parentheses. Again, we get the graph over here, and we can look at the intercepts. This is graphing a hyperbola. Again, you can kind of follow through that example and see how they do that. Then another example here, same kind of thing. You can see the hyperbola. Hyperbola are like two parabolas that go away from each other, basically, is what's happening there. And then something that you learned in geometry is the midpoint and distance formula. And the midpoint formula is right here. Basically, you're adding the x's, divide by 2, add the y's, divide by 2, and that'll give you the midpoint of a segment. And then you have the distance formula, which subtracting the x's squared, subtracting the y squared, adding those together, and then taking the square root will give you the distance from one point to the next. So this is also thrown into this section as well. Make sure you look at those. Hopefully they look familiar and you've seen those before. Also, be sure to look at the examples as you go through here. And the reason they bring up the midpoint and the distance formula is because you can use that to find the center and the radius of a circle. By knowing a couple of things about the circle, you can find the midpoint or the center of the circle by using the midpoint formula. And then you can find the radius of the circle by finding the distance of the diameter and then taking half of that. Okay, and then again, as you go through your online textbook and your course, you're going to notice there are the problems right here. Make sure you look in your course for week 1, the book assignment, and it will tell you which of these problems that you should do. Okay, so that's kind of just an introduction to conics there in section 1. Now we're going to break it down and talk about specific types. In section 2, we talk about circles. They're generally the easiest to talk about. There's a few things that we need to look at, but hopefully you're familiar with it as we go through this. Now, a circle, as you know, has a center point and then a radius out in any direction, and that radius is constant, and so that gives us a circle, that distance. When you're writing an equation of a circle with the center 2, 1 and a radius of 5, there's kind of a form that you want to follow as you go through this. And this is really what we're going to do for each section, for each of these conic graphs, is they're going to give us information about the graph and we have to come up with the equation, and then it's going to flip-flop. They're going to give us the equation and we have to be able to come up with a graph. So here they're giving us information about the graph, and we need to come up with the equation. Now there are some little hints, and you can see down here the equation of the circle. There are some little hints that might help us. The center of the circle is always going to be what you add and subtract to x and y. Okay, so it's the h and the k will give us the center. And so if the center is 2, 1, which it is in this example, you're going to do the opposite, x minus 2, y minus 1. And the radius is 5, and you always take that and square it, is 25. Okay, and you can see that here by the equation. So that's one kind of little trick to go from the center to the equation, or you can use what they have here as well. Let's go on then and take a look at this next example, writing the equation of the circle. So now they're giving us the graph again, and we have to come up with the equation. Notice the center is at 0, 0. So I'm not adding or subtracting anything to x and y. The radius I can notice here is 6. 6 squared is 36. This is my answer. If they give us the center point 2, 4, x minus 2, do the opposite, y minus 4. And then I actually have to go through and use the distance formula in this one to find the radius. So that's what this is all about. I find the radius to be 10, so 10 squared is 100. That fits my formula. A lot of good application problems for this because circles are all over the place. So you want to make sure that you understand some of those problems. And then finally they talk about a tangent. Now a tangent is a line that touches the circle in one point, exactly one point. So there's going to be a problem here where you're going to have to find the equation of a line tangent to this circle and its tangent at this point 3, 4. This is kind of a long process, so you really want to make sure you take the time and you look at this example. It goes back and talks about some linear equations and finding linear properties such as the slope and so on. So you have to be a little bit careful here and make sure that you read through this example before you try any of those problems. If you have questions with this, let me know. There's kind of a lot going on there. And then again, we have some problems that we're going to be doing here. So again, make sure that you take a look at that in your course and let me know how that goes. Then I quickly want to jump to section 3. We're also going to take a look at section 3. These are ellipses. Now ellipses have a couple of different points. There are things called the foci. Foci are 2 points inside the ellipse. The ellipse is kind of like an oval that sits out here. There is a distance formula to find what we call the constant sum of an ellipse. Basically, you're taking a point times the distance from the point to a focal point, and then a point to the other focal point. So it's a distance formula twice. You're adding that together to get your constant sum. Now we have other parts to the ellipse: major axis, vertices of the ellipse, the minor axis, and the co-vertices of the ellipse. Make sure you read through those so that you understand what those terms are. I want to kind of quickly go through this because I want to give you some hints again as to how to do some of these problems. Basically, you're going to have a horizontal left to right ellipse or a vertical ellipse. And then these are the equations for an ellipse. Now, I'll give you a hint that your a squared is going to be your denominator. Your a is the distance from the center out to one of the vertex points. Now, your a is going to be your larger denominator. If that's with the x variable, it's going to be horizontal. If a is with the y variable in the fraction, it's going to be vertical. Okay, the other part, the b part, tells you how wide that ellipse is. Okay, so as you look through these problems here, you'll notice again that we want to go from the graph to the equation, equation to graph. If I look at this one, I notice that here's my center at 0, 0. I've got a vertex point. This distance is 10, and it's going horizontally, so along the x-axis. So my 10 squared is my a squared. It's the 100, and it's with the x. How wide is it? Okay, I can find that by using this little formula right here, c squared equals a squared minus b squared, and I find my b squared to be 36. So this distance from the center out here is actually 6. Okay, so I can find my a squared and b squared pretty easily. Then going on, they're going to give us some other information here. Now I would take this and I would actually sketch out a quick graph of this. And when you do that, you're going to notice that this is actually a vertical ellipse. It's going up and down, and so my bigger denominator is going to go here with the y. You can also take the ellipse and you can move the center point around from the origin, and that just changes the x and the y parts of this. Here you're adding or subtracting something to x and y, and that just basically shifts that graph around. Again, your graphing calculator can help you kind of check some of those things as well as you go through. Another application problem, and then we have problems here for our exercises. Again, this can be a little bit tricky, so you want to take your time with these. Really take the week and focus on some of this stuff. If you have any questions, please let me know. Have a great week.